Hello everyone. Today we're gonna study differentiation for IGCSE, Cambridge and Edexcel. Then we'll do some questions from past papers. Be ready.
Are you feeling confused? You have problems in math? Our online courses will help you at any time.
The first thing we're gonna know what are the summary points of differentiation. The first thing is we will learn how to find the first derivative, how to find the gradient of the tangent to a curve, how to find the equation of the tangent, finding turning points and stationary points, then determine the nature of the points. So the first thing is, what's differentiation and how do we use it? We do differentiation to find the gradient of a tangent to a curve, and actually this is the accurate method. The accurate method, we use it to find the gradient for a tangent to a curve. So we find dy by dx, which is called the derivative of y with respect to x. So we do differentiation. So how do we differentiation? For example, if we have a function, it's called y equals x to the power of n. So the main rule is we multiply the power by the coefficient. Whenever we have a coefficient here is written before x, so we multiply the power by the coefficient, then we subtract 1 from the power. Like here we multiplied n by 1, it's kept as n, then we subtracted 1 from the power. We have an example here, y equals x to the power of 3. If we want to find dy by dx, what we will do is, we're going to multiply the power by the coefficient. 3 multiply 1 is 3, then we will subtract 1 from the power, it will be 2 instead of 3. So the final answer, the derivative of x to the power of 3 is 3x squared. So the first thing, you must be aware how you find dy by dx or the derivative of y with respect to x, because this will help us a lot in this lesson. We're going to do some examples on how to find dy by dx and more. Here we have a curve for a quadratic equation, and here is the line, the tangent, which is in the red color here. This is the tangent that touches the parabola or the quadratic equation in one point. If I want to find the gradient for this tangent, the proper way is we will find dy by dx, or the first derivative for this quadratic equation. We'll find dy by dx for the quadratic equation in here. Then we replace x by the given value. So for example, if I have the equation y equals x squared minus 5x plus c, 5x plus 6, for example, what we will do is we're gonna find dy by dx first, then we will replace in the derivative the value of x which is given. Maybe it will be required from you to find the equation of this tangent. As you know from the lesson of how to find the equation of straight line, you must know the gradient and the y-intercept for this tangent. So if you have the gradient after the derivative and you substitute it by the value of x, you need to get the y-intercept, then you can get the equation of the tangent. We're going to do an example on this part as well. Then we have the stationary points or the turning points. You must understand first of all what's the meaning of the turning point and the stationary point, which they are the same. Turning point, that means this is the point where the curve started to change its track. As you see here, here the curve was decreasing, then here it stops for some time, then it goes increasing, then stops, then decreasing, then stops, then it goes up. So the turning point, the point where the curve it changes its direction or its track, and or the point that the curve stops exactly, or we can say the point that the gradient is 0 at this point. As you see here, there is a tangent at this point, so the gradient is 0 because it's parallel to x-axis. Here the gradient is 0, and here the gradient is 0. So the stationary point occurs when dy by dx is 0. How do we find the stationary point using differentiation? You will differentiate first, and then we will equate the derivative to 0. After that, I will try to solve the equation in x, finding the value of x, then I will get values of y, and we're going to show you some examples on this part. The last thing is the second derivative. How do we use the second derivative? Actually, we use the second derivatives in finding the nature of the point. If the turning point is minimum or maximum. What's the second derivative? After you found the first derivative by differentiating, you will do differentiation one more time. Then after you differentiate, you're gonna use x values. We have d squared y by dx squared. So we'll replace x values here. If the x value after replacing, the answer is positive, so the point is minimum. If we replace the x value and the answer is negative at the end, so the point is maximum. I will do one example on this part or two so you can understand this point. We need to find, the first part says differentiate x squared plus 3x minus 4. Then we need to find the equation of the tangent with the curve at the point 2 and 6. How do we differentiate? To find the dy by dx, the first thing is you need to do, as I said, we're going to multiply the power by the coefficient. What's the coefficient of x squared? It's 1. 2 multiplied by 1 is 2. Then subtract 1 from this power, so it will be x to the power of 1, and no need to write 1. Here we have plus 3x. You must know something very important. 3x, or whenever we have a number and we have x to the power of 1, once you differentiate, the x will be removed because power 1 here, 1 multiplied 3 is 3. Then if you subtract 1 from this power, it will be x to the power of 0. And here minus 4, it doesn't have x at all, so the derivative of this one will be 0. So again, whenever we have, this is a special case, whenever we have a number and we have x to the power of 1, once we differentiate, we'll multiply the power by the coefficient. 1 multiplied 3 3. Then here we're going to subtract 1 from this power, it will be x to the power of 0. Whenever we have a constant or any number that does not have x, when you differentiate it, it will be 0. So simply this will be written as 2x, and here 3x power 0, this will be converted into 1, so it will be 3. And this 0 can be removed. So you can conclude in this point, once you differentiate any number that has x, any number is followed by x here, just remove the x and keep the number. When you have any constant, its derivative is 0. So at the end, this one is 2x plus 3. This is the derivative. Now, we need to find the equation of the tangent. To find the equation of the tangent, you must know the gradient first and then the y-intercept. So to know the gradient is the derivative, the first derivative, and then you replace x by the given value, which is 2. So what was the derivative? The derivative is 2x plus 3. Then you will replace x by 2. It will be 2 multiplied by 2. Then you add 3. So 2 by 2 is 4 plus 3, which is 7. So the gradient is 7. So again, how do you get the gradient? You will differentiate, then you will replace each x in the derivative by the given value or the given value in the point. So you replace the x's. Now we have the gradient, which is 7. We need to find the y-intercept, since the tangent is passing through this point, which is 2 and 6. Go in the equation, just replace x by 2 and the y by 6, then you can get. So the equation now is y equals 7x plus c. Just replace the x by 2 and the y by 6. So it will be 7 multiplied by 2. And here the y replaced by 6, then plus c. This one will be 14. And this one is 6 plus c. Just shift this one there. So the c will be negative 8. Now you have the y-intercept and you have the gradient. So your equation will be at the end y equals 7x minus 8. This is the one which is required. So let's move to see one more question. Here is a question asks for finding the gradient of the curve when x is negative 2. So we need to find the gradient for the tangent to this curve when x is negative 2. So first of all, you need to find the derivative, and then you will replace each x by negative 2. The derivative, you're going to multiply the power by the coefficient. 3 multiplied by 2 is 6, x to the power of. Subtract 1 from the power, it will be power 2. Then, as I said to you in the previous example, whenever we have a number and followed by x in here, just remove the x and keep the number, and the constant, its derivative is 0. So now you got the first derivative. So what you will do is you're going to replace each x by -2. It will be 6 multiplied by -2 all squared, then minus 7. So it will be 6 multiplied by 4, then minus 7. So it's 24 minus 7 equals, at the end, equals 17. So the gradient at this point is 17. So again, what did we do? We differentiated first. Once we are required to find the gradient, you will find the first derivative. Then you replace each x by the given value. So here 2 by 3 is 6. Subtract 1 from the power, it's 2. Then whenever we have a number is followed by x, its derivative is the number only. So minus 7x, its derivative is minus 7. And 4, it has no derivative because the constant will be differentiated as 0. So now we got the derivative and we replaced each x by -2. We got 17 at the end. Let's see one more example. We have this example says find the equation of the tangent to the graph of y equals x to the power of 3 minus 4x squared plus 4x at x equals 4. Give your answer in the form y equals mx plus c. So in this part we need to find the gradient and we need to find the y-intercept. We have y value only. We have x value only. So you need to have a complete point in here. You need to have a point, x coordinate and y coordinate, because you will use it later on to substitute to find the y-intercept. So whenever you are given only the x coordinate and it's required to find the equation of the tangent, you must first of all find the y coordinate. How you will find y coordinate? Go to the original equation of the curve, replace each x by 4, so it will be 4 cubic, then minus 4 multiplied by 4 squared, then plus 4 by 4. This at the end will be 16. So when we have x is 4, the y coordinate is 16. So again, whenever it's given for you only the x coordinate and it's required for you to find the equation of the tangent, you must find the y coordinate as well by replacing each x value in the original equation of the curve, so you will get the y value. Now we have the point 4 and 16, that that's the intersection point between the tangent and the curve. Now we need to find dy by dx. It will be 3 multiplied by 1, the power multiplied the coefficient, 3 multiplied by 1, which is 3. Then subtract 1 from the power, it will be 2. Minus 2 by 4 is 8. Subtract 1 from the power, it will be power 1, and we will not write power 1. And then 4x, as I said before, whenever a number is followed by x, just keep the number. So the derivative of 4x is 4. Now we got the derivative. So the gradient is the derivative, but we replace each x by the given value, which is 4. So it will be 3 multiplied by 4 squared, then minus 8 multiplied by 4 plus 4. So this one will be 3 by 16, which is 48, minus 32, then plus 4. So it will be 20. So the gradient is 20. Now we got the gradient. We need to find the y-intercept. So the equation is y equals 20x plus c. We need to find c. You have the x coordinate and y coordinate, the point that belongs to the tangent. So what you will do is you're going to replace each x by 4 and each y by 16. So 16 in here equals 20 multiplied by 4, then plus c. So it will be 16 equals 20 by 4 is 80, 80 plus c. So just shift this one there. It will be 16 minus 80 equals c. So c is negative 64. So now you have the y-intercept and you have the gradient. So the final form of the equation is y equals 20x minus 64. And this question is done. Let's move. question. The question says, a curve has equation y equals 2x to the power of 3 minus 4x squared plus 6. Find dy by dx, the derived function of y. Calculate the gradient, then find the coordinates of the stationary points. So the first thing, let's find the derived function of y, dy by dx. So it will be multiply the power by the coefficient. 3 by 2 is 6, x then power 2, because we subtracted 1 from the power, minus 2 by 4 is 8, subtract 1 from the power, it will be x. And here, no need to do anything because the derivative for the constants only is 0. So we got the derivative. Calculate the gradient. The gradient actually is the derivative, but we replace each x by the given value. So dy by dx, it will be 6x squared minus 8x, replace each x by 4, so it will be 6 by 4 squared minus 8 by 4, so it will be, here we have 4 squared is 16, so we can calculate this one, 6 multiplied by 16, then minus 32, so we get the gradient. Here we have 16 multiplied by 6, 96 minus 32 equals 64. So the gradient is 64. Now, if we want to find the coordinates of the two stationary points on the curve, to find the coordinates of the stationary point, the steps are, first of all, you find dy by dx, then you equate dy by dx to 0, so you will have an equation. Solve the equation, get x values, then get back to the original equation, replace each x, you will get the corresponding y values. So these are the stationary points. So let's do the steps. The first thing is, we got already dy by dx. We need only to replace it or equate it to 0. So the first thing is, here we have dy by dx equals 6x squared minus 8x. Equate this one to 0, so it will be 6x squared minus 8x equals 0. So here it will be, we're going to take 2x as a common. So what will be remaining? 3x minus 4. So maybe x is 0 or x is 4 out of 3. So now we have the two x values. So let's get the y values. You will get back to the original. So the first y will be 2 by 0 cubic minus 4 by 0 squared, then plus 6. So the y will be 6. So when x is 0, the y is 6. The other one is when x is 4 out of 3, so it will be 2 multiplied by 4 out of 3 cubic minus 4 multiplied by 4 out of 3 squared, then plus 6. So if we calculate this one, it will be 2 multiplied by 64 over 27, and then so it will be here 2 multiplied by 64 over 27 minus 4 by 16 out of 9, then plus 6. So 63 approximately. So the point is 4 out of 3 and 3.63. So let's move to one more example. The question says, find dy by dx, y equals x cubic minus 2x squared minus 15x plus 5. So to find the derivative, we will multiply the power by the coefficient. So 3 multiplied by coefficient 1 is 3, then it will be x power 2, minus 2 by 2 is 4, x, then minus 15, as you know, because whenever a number is followed by x, we just remove the x and keep the number. So we got the derivative. Then it says C is the curve with equation y equals x cubic minus 2x squared minus 15x plus 5. Work out the range of values for x, which C has a negative gradient. So here we have the gradient, which is already dy by dx. And we don't have the value of x to replace it in here, so we get the gradient. But it's negative gradient. Negative gradient when the dy by dx is less than 0. So this part, it means dy by dx is less than 0. So let's take the dy by dx and make it less than 0. So we'll solve an inequality to find the range of x values. The derivative was 3x squared minus 4x minus 15 less than 0. So we need to factorize here. We will consider this as an equation. So if we factorize, sorry, consider it as an equation. So if you consider it as an equation, you're going to find the first x and the second x. Factorization, negative 5 out of 3. So now the range will be, here we have it's less than, so x will be between, as you know here in the number line, it's negative 5 out of 3, and here it's 3. So x will be here, this is the positive part of the quadratic inequality. This is similar to a, and this is different from a. So the x is between negative 5 out of 3 and between 3. So this is the range of the x values for this question. Let's see one more question. Equation. A curve has equation y equals x power 3 minus 3x plus 4. Work out the coordinates of the two stationary points. So to find the stationary points, first of all is we'll find dy by dx. It will be 3 multiplied by 1, which is 3. Then x, remove 1 from the power, it will be 3x squared minus. Whenever a number is followed by x, just its derivative is the number and remove the x, and 4 has no derivative. Then equate this derivative to 0. Solve like an equation, it will be 3 and then x squared minus 1 equals 0. So it will be x squared minus 1 equals 0 because we divide by 3. We divide by 3. So x squared is 1, so x is 1 or it's negative 1. So these are the two values of x. Let's get the values of y. So x maybe is 1 or negative 1. If you replace it in here, 1 cubic minus 3 multiplied by 1 plus 4. So it will be 1 minus 3 plus 4. It will be 2 because 1 plus 4 is 5 minus 3 is 2. So when the x is 1, the y is 2. The other y, when it's negative 1 cubic minus 3 by negative 1, then plus 4, it will be negative 1 plus 3 plus 4. It will be 7 minus 1, which is 6. So the other y is 6. So now we got two values, 1 and 2, and negative 1 and 6. We got the stationary points. So how do you find the stationary points again? You find dy by dx, then you take the derivative, equate it to 0, solve like an equation, get x values, then substitute the x values in the original equation to get the y values. Now, how do we determine whether each stationary point is minimum or maximum? This is the way. We find the second derivative first. So d squared y by dx squared. We will differentiate one more time this one. 2 by 3 is 6. Then x power 1 because we'll subtract. And the 3, it has no derivative. So the second derivative is 6x. what you will do in the second derivative. You will find what's the value of the second derivative when x is 1 or x is negative 1. So you're going to take the x coordinates of the two stationary points. So you're going to write at x equals 1 and then at x equals negative 1. So when x equals 1, d squared y by dx squared, it will be 6 multiplied by 1 equals positive 6. And when it's at negative 1, it will be d squared y by dx squared equals 6 multiplied by negative 1, which is negative 6. So now we got the second derivative is positive when we have x equals 1. So when the second derivative is positive after substitution, so this point is minimum point. It's a minimum point. And this part is a maximum point. So you can mention now that the point 1 and 2 is minimum point, and the point negative 1 and 6 is a maximum point. And no one says whenever x is positive it's minimum, whenever x is negative it's maximum. No, some cases it's different. So you should follow the method, which is finding the second derivative, then you replace the x coordinates of the stationary points. If the answer is positive, so it's minimum. If the answer is negative, it's the only stationary point on the curve with the equation y equals kx squared plus 16 over x, where k is a constant, given that the coordinates of a are 2 over 3 in x coordinate and a in the y coordinate. So if someone says we have already the x coordinate of the stationary point, so we'll just substitute the 2 over 3 in this form, so we get the y coordinate. Unfortunately, you don't know what's the value of k. So first of all, you must get the value of k, then you'll be able to find a. So first of all, let's write this in a form which will not have fractions. It will be kx squared then plus 16. If you take this one up, it will go with the negative power. It will be 16x power negative 1. So now we will go in the regular steps of finding the turning point, which is getting the derivative first. So it will be multiply the power by the coefficient. It will be 2k. Then subtract 1 from the power. It will be 2 multiply k is 2k x power 1. Then negative 1 by 16 is negative 16 x power. We have minus 1. When you subtract 1 again, so it's minus 1 minus 1, it will be minus 2. So now we got the derivative. Again, we multiplied the power by the coefficient. 2 by k is 2k. And the x, when we subtracted 1 from the power, it becomes x. And here, negative 1 by 16 is negative 16. When we subtracted 1 from the negative 1, it becomes negative 2. After we're finding the dy by dx, what we're doing, we're equating dy by dx to 0. So it will be 2k x minus 16 x power negative 2 equals 0. Now you have the x value. You have the x value already. So you can replace each x by 2 over 3. So it will be 2k multiplied by 2 over 3 minus 16 multiplied by 2 over 3 all power negative 2 equals 0. So this one, it will be 4k out of 3 minus, if you do 2 over 3 all power negative 2, it will be equivalent to 3 out of 2 all squared, because we know we flip these two together and the power changes, so it will be 9 out of 4. So it will be 16 multiplied by 9 out of 4 all equals 0. So now it's still 4k out of 3 minus 16 multiplied by 9 out of 4. So you can simplify here. Divide by 4 is 1, divide by 4 is 4. So 4 by 9 is 36. Now you have an equation in k, so you can find it simply. 4 over 3k equals 36, because we shifted this to the other side. So now k will be 36 divided by 4 over 3. So k will be 36 multiplied by 3 out of 4. Divide by 4 is 1, divide by 4 is 9, 9 by 3 is 27. So the value of k is 27. So you can get back to the original equation, replace the k by 27. Let's go, let's get back to the equation here. It will be y equals 27 x squared plus 16 out of x. Now if you want to find the y coordinate and you know already the x coordinate, so what you will do is you will replace each x by 2 out of 3, so it will be 16 over 2 out of 3. So y which is the a here, the a is the y coordinate, so here it will be 27 multiplied by 4 out of 9 plus, here we have 16 divided by 2 over 3, 16 by 3 all over 2, it will be 24. So it will be here, divided by 9 is 1, divided by 9 is 3, so it will be 12 plus, here this one will be 8, it will be 24. So the a value is 36. So the y coordinate is 36 when the x coordinate is 23. So now we got the k value and we got the a value. Today's video is done. I wish you got the differentiation very well.